I'm CK. Tonight we've got another kit from the Dingdong Store. They have really good kits I've been finding. Tonight it's another digital clock. Looks like it'll be kind of fun to put together. Lots of good soldering. We'll see how it goes, and I hope you enjoy the video. Here's the box. Dingdong Store, 60-second electronic clock. I believe that's the S stands for second because I believe there are 60 LEDs, which will be fun. Let's see what we got. Got a nice piece of paper. Looks like the same standard packaging for Dingdong Store. Good little thing. Contact them if you have any problems, which is nice. I haven't had to do that, but here's the parts list. 5-volt USB or battery, but we'll use USB. Got a 3.3 volt SMD button battery, Note B, 1220 button battery, so it comes with a battery too. Oh, that must be a backup for the clock. 52 blue LEDs and 14 red LEDs. Okay. A buzzer photoresistor, so it'll dim, I guess. Nice transistors, some resistors, a thermistor. Wonder why it has a thermistor in there. Huh. A switch, a clock display, a STC microcontroller, a DS1302, I don't know what that is, a 32 kilohertz chip to keep time, and some sockets and a PCB. That's pretty straightforward. Do they have a schematic? I do not see a schematic here, but before we start, I'll link to the QR code. You know, QR stands for quick response. Did you know that? And we'll take a look at that. But let's look at the parts inside first. Here we have a somewhat standard acrylic case. These are a little pain. They're always painful to put together, but we'll do that. And then here is the component bag. Let's get the box ready for recycling. And where's my silver parts tray? Where's my parts tray? There it is. It's got parts from my last kit. Huh. Dump those out. USB cable, as if we all didn't have like 18 million of those. Here's the parts. The instructions again in Chinese with the parts list. And this has the schematic. Gosh, it's really hard to read. I assume it'll be in the PDF we can download too. It's got a little speaker for a buzzer. And here's the microcontroller, all the pinouts on that again I can barely read. Momentary switch, the display, all that kind of stuff. Here's the circuit board with the battery taped to it, the 1220 3 volt battery. Let's take it off the circuit board. I think it's leaving some residue too. Yeah, it's leaving some residue too. I will clean that off camera before we get started. Oh, look at this. It's digital, but it also looks like it's got a regular clock face display on it too. Maybe that's where the red LEDs go. Here's the back. And the resistors have their values listed. All of them this time. 2 switches. Button battery goes here. The little buzzer goes here, I believe. Transistor goes here. The processor goes there. Microcontroller goes there. And then there's some flat contacts. I don't know what that's going to be for. Maybe I'm not seeing where the USB power comes in, that may be here. We'll check that as we go along. So a bunch of soldering to do on the LEDs, but as I'm looking, I can see a clear plus sign for the long lead on the LEDs, so that's nice. So it looks good. Got some resistors. Here's the little battery box. This is that DS1302. I will look that up. That's probably a clock, but I don't know for sure. It's the microprocessor, microprocessor and its socket with lots of LEDs stuck to it. I'm going to take the tape off of this too, get all the tape out of the way at one time. Here's the little buzzer. These are very common, very standard pieces of electronic gear. You probably have a bunch of them around you. Here's the USB connector, and I was wrong. This will not go there. It'll go right here. I'm probably poking out the back of the back panel. I think the back panel, yeah, the back panel's got all the ports because we've also got the switches that'll go in there, and they'll stick out the back like so. But I'll take that back out for now. There's the display, the digital display. 1/10 of a microfarad cap, capacitor that is, or if you're old like me, condenser. So it's pretty simple in terms of variety of parts. And here's the photoresistor, which I assume is going to allow us to dim the light. Here, this should be the crystal. I believe this is the 32 kilohertz timing crystal. And that's about it. So we'll get the soldering iron heated up and I'll be off camera cleaning up this circuit board before we start. I'll wash it off with some isopropyl alcohol. That should take this tape schmutz off it. So we'll put this together. Isopropyl took the tape goo right off. They do have a good PDF build guide. Lots of pictures, which is really good. And yeah, the red LEDs are to mark the hours. And then how to read resistors. And not much, just one big picture, which is not bad. So that's it. And also the DS1302, I was right, that is the clock chip. And besides being simply a clock, it also has 31 bytes of static RAM to store the time. And I'm looking, yeah, the chip, the timing crystal goes here and lays flat. I don't know if it needs to be soldered to this pad or if that's just I don't know. We'll see when we get to it, when we start fitting it in. But the first thing we're going to do is we're going to do our resistors. Oh, by the way, the circuit board is very good. It's through-hole plated, which for kits at this price range is not standard. They're usually they're usually just surface etched, but the through-hole means you probably will not have cold solder joints or anything like that. Let's see, do we bend the bodies right up, the leads right up against the body of the resistor? No, we gotta put probably 2 millimeters on either side. The spacing is pretty broad on that. That's interesting to note. Let's solder one to see how the board takes solder. And I washed it with isopropyl alcohol, so it should be pretty good. Oh yeah, that takes solder very well. The other thing I'm noting here, I'm sure you can't see it, there's a whole bunch of test points on the board, which is, again, unusual. This is a relatively simple circuit, but it's good. So that's our first live resistor, and there's nothing much more to say about resistors. So I've got these 8 or 9 or 10 resistors to put on, and I'm not going to continue live commentary. I'll speed up the video playback as all these resistors fly onto the board, because, as we like to say on my channel, it's resistor time. And that's all the resistors on the board. Looks like they gave us a spare 10K, which is good. Put it in the spares box. As you build these kits, particularly from some of the places like Dingdong, they throw spare parts in here, which I appreciate. And if you're just starting out, it's a good way to collect a bunch of parts. What do they want us to do? Resistors, and then the capacitor and the oscillator. Install capacitors, it says. Oh, there are 2. Okay, good. I was a little worried about that, because I only remembered seeing 4, C1 and C2. Here's C2. It's funny, the printing is half that way and half that way, so some of it seems upside down at certain points, but it's not. It's just whatever it did. Now we'll put the timing crystal on also. And when we put this on, it goes here. Crystals are, in general, not polarized, so you don't have to worry about which way it goes. What you do have to worry about, or think about, is it's not going to be standing up, it's going to be laying down. So you don't want to push it all the way, the leads all the way in the holes, because then you can't bend it over. So we'll just do that, and I think I'll solder those components down right now, because the crystal leads are a little bit short, and I don't want anything falling out. Okay, so now we're going to put the button battery on, and the leads are flat leads, so they don't go through the board. So what I'm going to do, where did I put my solder? What I'm going to do is what I do with surface mount components, is I'm going to put a little dab of solder on each pad, then bring this over. It's got 2 centering pins on the bottom, and I'll put it in the centering pin place. Then I'll heat the terminal here, and you can see the solder flow around it, and that's down. Always wait for the solder to cool, because if you're impatient like me and you bring your soldering iron away and then let go of everything, it won't necessarily cool, it'll shift around. And that one's good. So they're both soldered down. Again, that's just going to be for the backup to the clock circuit. Now we'll put the sockets on, and again, there are many kits like this you'll find on Amazon or eBay or Ali that do not come with sockets because it's extra cost. They just have you solder the chip directly to the board. For something like this, you know, it doesn't really matter. So I'm supporting the socket with my pinky finger on the back. I'm going to solder one leg, let it cool. Now look and see, I didn't do it well. See that? It's all up at an angle. And that's why we only did one leg, because I'm going to heat that leg again and press it flat. Hopefully you heard the little click, and now it's all flat to the board. Easy as 3.14. Put the other socket on also, making sure the notches are going the right way, of course. And that went on fine. Let's zap all these legs down. And that's the socket holes. The sockets are all in. Now we'll do the power interface, the triode, photoresistor, thermistor, and buzzer. And now we're going to put the display on next. And it looks like these pins got really bent during shipping. Yeah, that one's even almost like a hook. Now I use needle nose pliers to dress up pins on pretty much everything. They work really well. They allow you to get things aligned nearly parallel, so they're handy to have. And we're going to put it here, and if you'll notice on the board there are dots that correspond to the dots on the bottom under the display, so you know which way it goes, how it's oriented, so you don't have to worry about your numbers being upside down. Oh, come on. Okay, I've got the one row in. I gotta tweak the pins a little bit on this row. There we go. And while I did that, the other row came out. Of course it did. There we go. Now it's settled in. I think I can just, yeah, that'll set down there well. Do one pin. That's not down. There we go. You probably could hear that. These Nikon mics that I use, pretty good. This actually is not. Oh, look at that. So the pins from the socket, this socket, the clock chip socket, are too high, and they're keeping the display from settling completely on the board. So I'm going to take the display back off. And before I forget, where's my solder sucker? Before I forget, I'm also going to suck the solder out of that hole I had. So I don't go back to doing it and saying, man, it won't go through, it won't go through. Okay, so what I'm going to have to do is just trim these with my flush cutters. Just take the excess pin part off. It's not, you don't have to dig into the solder balls if you don't want to. There we go. And now that will sit flat. The socket pins are no longer interfering. They won't. Actually, let me take a look. Now that I've got the back panel kind of sorted out here. And it is resting on, okay, the chip, the microcontroller will be right here, will be the highest component, so I don't have to worry about those pins. Where am I next? Okay, now we're going to do all the LEDs, 60 of them or so, whatever. I can't do math really well. So first thing I'm going to do is put the red ones at the hour markers. There's all the red LEDs. And now all the blue LEDs. And we'll speed through all these, of course. All the LEDs are on and all the soldering is done for this kit. Now one thing I'm going to do before we go further is I'm going to take a look at all the solder joints and make sure primarily I didn't bridge them. The LED points are close together and you can bridge easily, but they all look good. Now I'm going to do two things. First I'm going to get this little backup battery into its holder. Oh man, that's got tape residue all over the back. Let me go clean this off, even though it doesn't really matter since this is a side connect, not a back connect. But come on guys, oh, I gotta put it in the right way. You gotta put it in the right way. There it goes. I'm going to peel the little sticker off the buzzer. I'm going to put the ICs in now also. Bend the legs in a little bit on the side of my workbench. Find the notch. Verify that it's the notch on the circuit board, not just the notch on the socket. And I didn't bend, I need to bend the pins in a little bit more. All in, no pins bent on that one. Now we take the little clock chip, bend those pins in a little bit too. I went a little too far on those because since there's only 4 per side, they bend easier. There we go. Now let me look at the build guide again just to make sure we're going at the same rate. Now let's see what they say about putting the case together. Ah, see, they don't even talk about the case. I wish the schematic that they provided wasn't so blurry. So we're just going to put the case together. This may be challenging or irritating because they don't have the directions for this, but it's not too bad. It's irritating, but not too bad. So this will be the back, of course, because it's got the holes for the switches and the buzzer and the USB connection. Now, what we're going to do is figure out where the things go. Make sure, because there are 2 different sizes of side pieces. I believe they're different sizes. No, they're apparently all the same size. Okay. So I'm going to put this one in first. And again, I find these painful. You drop the nut into the little notch. And take your screw. And put your screw in there. Straight so it doesn't cross thread, because you don't want to be like my old co-worker Larry way back when I was an airplane mechanic. One of his favorite sayings was, "Nothing's tighter than a good cross thread." And while that may be true, may be factually accurate, not the way you want to live your life. Come on, stupid nut. I want to see something here because I really don't know how this stays stable inside here. It's got, I guess it press fits in okay. Get through the switches through the holes. No, it's loose. See, it's got 4 holes, 1, 2, 3, 4, to mount it, but they don't give us any hardware to do that. So it's just going to be a press fit, which is not great for the fact that it's got, or friction fit, the fact that it's got a USB connection you have to push in and out periodically, or could be doing that there. I guess it's not shaking around. So that's it. Now, let's do the interesting part. And let's turn it on. Let me get the USB cable. And I'll turn off this light, even though that doesn't make a whole lot of difference because the cameras compensate so quickly. Plug this in. There we go. It's blinking. Now beep. Set this for what time it is. What time is it? 1:30. Press number 1 button to switch LCD rotation mode, and look, one red LED is dead, looks like. Time adjustment. Press button number 2. Which one is button number 2, just to make sure. So this is button 2. Number 2 to set the minute of time. Yep, 18 degrees C, so that is a thermistor. Huh, 2 red LEDs are bad, huh. 18 degrees C, and that, which I don't know what that, and there's rotation. If you want that to happen. Different rotation modes. I would think there would be one that's just counting out the seconds like a second hand, but I'm not seeing that. Okay, so that's nothing. So press button number 2 to set this time. Okay, the clock isn't working. Something is goofy here. I mean, obviously, could be the chip, the programming in the chip, but this is not working like a clock. So it's okay soldering kit, but it doesn't really do what it's supposed to do. There's the temperature display, and there's the clock display, but it's almost I don't even know what the heck is going on here. Okay, I don't know what it's doing, and it's not working. But that happens. Maybe you'll have better luck with this actually working. But in general, the quality of the kit is good, the materials are good, the circuit board's good, and the soldering is good practice. Unfortunately, I can't get it to actually work right, but that happens sometimes. Thanks for watching the video.